In this video, we will learn how to calculate the molar mass of an element and compound. Molar mass is the mass in gram of 1 mole of the compound. So normally molar mass is measured in gram per mole. Let's look at some examples. We have O2. O2 is an element. Oxygen, we're asked to calculate the molar mass of oxygen. So we're going to use this 2, using 2, and then times in about 16, and 2 times 16 are going to give us 32 gram per mole. Let's look at here. How did we get the 16? We got the 16 from the periodic table. For example, we have Na. Na, we have 22.98 and 11. Suppose this 22.98 is what we're using here. It's normally what we're using, and this 22.98 is what you call the atomic mass. So in calculating molar mass, we don't use atomic number, but we use atomic mass. Similar example is hydrogen. Hydrogen atom is 2. Consider by the atomic mass, we're going to get 22 gram per mole. We also have water. Water is H2O. So we list the element. We have hydrogen, we have oxygen. Hydrogen here is 2 times. Oxygen here is 1 time. And so we're going to times the amount of time they appear by the atomic mass. So 2 times 1 giving us 2. And then we have oxygen is 1 times 16 giving us 16. 2 plus 16 give us 18 gram per mole. This becomes the molar mass. Let's look at some examples. Suppose you are asked to calculate the molar mass of sodium hydroxide. Sodium hydroxide is NaOH. NaOH is sodium hydroxide. So we're going to list the element. Here we have sodium, we have oxygen, and then we have hydrogen in sodium hydroxide. So sodium obviously is appearing 1 time, oxygen is 1 time, and hydrogen is 1 time. So we're going to times all this number by the atomic mass. So sodium atomic mass is 23, and then 1 times 23 will be equals to 23. Oxygen atomic mass is 16. So 1 times 16 gives us 16. Hydrogen atomic mass is 1. So 1 times 1 will be equals to 1. So we're going to add all these numbers, 23 plus 16 plus 1. And total going to be 40 gram per mole. This becomes our molar mass. So move to our next element. Our next example is iron. Is iron 3 nitrate, iron 3 nitrate, FeNO3, and then we have 3. So we list the elements. Here we have Fe, and then we have nitrogen, we have oxygen. So F is 1 time, nitrogen is 3 affecting nitrogen, so nitrogen is 3 times. Oxygen, this 3 also affect oxygen, but we have another 3, so we say 3 times 3. Obviously, it will be equals to 3. So we also times this number by the atomic mass. So 3 times 16. Obviously, will be I'm making this a mistake. We say F is 1 time, nitrogen. This 3 affect nitrogen, so we get 3. This 3 also affect oxygen, so 3 times 3 give us 9, of course, yes. So we have 9 oxygen here. So 9 times 16 now will be equals to 144. So also times this, nitrogen atomic mass is 14. So 3 times 14 will be equals to 42. And then we times iron atomic mass is 558.8, so it's going to be equals to 55.8. So we add all this number, 55.8 plus 42 plus 144, so we're going to get 241.8 gram per mole. This becomes the molar mass of Fe. So let's look at some example. Suppose you have the molar mass of Benchmark 3 nitrate. Benchmark is the atomic mass of Benchmark is the atomic formula of Benchmark is the molecule, the atomic mass, total atomic mass, we were asked to find the molar mass of Birchmont. Obviously, the formula of Birchmont is Bi or NO3 to 2. So we're going to list the element. We have Bi, we have N, and we have oxygen. So Bi is 1 time, and here is of course these 2 affecting N, so it's going to be 2 times. Of course, these 2 also affect the oxygen, so T times 2 is obviously 6. So we times 6 by 16. We're also going to times 6 by 14. We're going to times this. The Bi is normally 209. So 1 times 209 gives us 209. And then 2 times 14 will be equals to 28. And 6 times 16 will be equals to 96. So we're going to say 96 plus 28 plus 209 will be equals to 33 gram per mole. Okay, let's look at our last examples. In our last example, suppose you're given a carbon dioxide. So carbon dioxide is CO2. You're asked to find the molar mass of carbon dioxide. So we list the element. We have carbon, and carbon dioxide, we have oxygen. So what we're going to do is we're going to say carbon there is 1, oxygen there is 2, so times 2 by 16. Obviously, this oxygen going to be equal to 32. So we're going to times this carbon by 12. Obviously, carbon is 12. So 12 plus 32 will be equals to 44 gram per mole. So our last example is methane. So methane is CH4. So methane is CH4. So we have 1 carbon and 1 hydrogen and an hydrogen in methane. So how many hydrogen do we have? 4 hydrogen, and then we have 1 carbon. So we're going to times 1 by 12. We're going to times 4 by 1, and then we'll get 4 here, and 1 times 12 is 12. So if we add all, we'll get 16 gram per mole. This becomes our